What is a class? A class is a programming structure used to define a general model blueprint of something, such as a video game character, together with a set of methods that control its behavior, such as making it move, jump, and so on. For example, suppose we want to design a program that includes a variety of cars. A straightforward beginner approach would be to write separate code for each individual car. But what if the number of cars is large? Say 100, and each car requires 50 lines of code. That would mean writing 5,000 lines of code just for the cars. Clearly, this is not an efficient way to handle programming tasks. Python provides an excellent mechanism to reduce this massive amount of code and save both time and effort in such cases. This is achieved by using a class. A class serves as a general table for these cars, from which we can then create individual cars, each with its specific properties. In summary, a class is one of the most powerful features in Python. It helps reduce code duplication, maintain organization and clarity, simplify development and maintenance, and save a great deal of time and effort, especially when dealing with advanced or complex scenarios. Before we begin, I encourage you to watch this explanation all the way to the end, even if it doesn't make sense at first. It's completely normal if the flow feels unclear during the initial walkthrough. The key idea and the real understanding behind everything we discuss comes together at the end, when we create a specific object from the class. For that reason, it's important not to skip any part of the explanation. Stay with it until the very end and enjoy the lesson. This is the general form of defining a class in Python. We can break down the process of defining a class in Python into 4 main steps: Step A, Step B, Step C, and Step D. Step A. We begin defining the class by using the class keyword, followed by choosing a name for it. Here, we chose the name robot, starting with a capital R. By convention, class names start with a capital letter to distinguish them from functions when they are called later. We then end the line with a colon to make the indented lines following it subordinate to the class. In the next line, we add an optional indented docstring which briefly describes the purpose of this class. Step B. Also indented inside the class body, we define the init method. Defining a method inside a class follows the same steps as discussed earlier in the book on how to define a function, using the def keyword. Pay attention, when writing init, it begins and ends with 2 successive underscores. Inside the parentheses of this method, we add a set of parameters that allow us to specify the properties of the object we will create later from this class. In our example, we added a parameter named name to specify the object name, and another named color to specify its color. Concerning the first parameter, self, it is mandatory to always include it first. We do not pass an argument to the parameter self. Instead, Python automatically assigns the object we create from the class to it, and we do not call the method init manually. This method is automatically called by Python whenever we create an object from the class. In the next line, with an additional indent inside the init method, we add an optional indented docstring which briefly describes the purpose of this init method. Step C. At the same indentation level inside the init method, we define a set of attributes that represent the common properties of the general model. These attributes are used to store the specific properties for each specific object we create from the class. In this demonstrative example, we added the attribute self.name, intended to represent the name of the object we create from this class, and we set its value to name, which is the parameter we added of the method init, in order to update the value of this attribute by the argument passed to that parameter. In the next line, also inside the body of init, we also added another attribute, self.color, intended to represent the color of the object, and assigned to it the value color, which is the parameter of init, to be updated via the argument passed to that parameter. Of course, we can add much more attributes when needed. Step D. We return to the first indentation level staying inside the class but outside the init method to define the class methods. These methods allow us to control the objects we instantiate from this class later on. As mentioned earlier, defining a method within a class follows the same steps as defining a function, with the addition of the self parameter. For demonstration purposes, we have defined a method here named sit, intended to indicate that the object we create from this class is sitting. Inside the method, we include an optional docstring explaining its purpose, followed by the operation itself. In this case, the method simply prints a sentence for demonstration purposes. However, in a real-world scenario, a method could be programmed to make an object physically move or perform complex actions. At this stage, we have finished defining the robot class. This class serves as a blueprint, allowing us to create any number of robot objects, each with its unique name and color. Creating an object from the class. Creating an object from this class is straightforward. We simply call the class by its name and pass in the necessary arguments. These arguments are routed to the parameters defined in the init method. For example, to create a white color object named Eve, we call the robot class and provide the specific properties for this instance. We pass Eve as the argument for the name parameter of init and white for the color parameter. For demonstration, we stored this new object in the variable named robot1. A quick walkthrough of what happens when this code runs. In this line of code, we are creating a new object from the robot class blueprint. We are naming the robot Eve, assigning it the color white, and storing this new object in the variable robot_1. When Python executes this line, it automatically calls the init method to initialize the object. During this process, Python passes the newly created instance robot_1 to the self parameter and passes our arguments to their corresponding parameters. The string Eve is passed to the parameter name and white is passed to color. As a result, the object's attributes are set according to these arguments, leaving us with a fully initialized robot named Eve, colored white, that we can easily access through the variable robot_1. Calling a class method. We can call any method defined inside a class on any object created from that class. Once our object is created and stored in robot_1, we can call the sit method defined inside the class on this object. This is done simply by typing the variable name in which the object is stored, followed by the name of the method we want to call, in our case, sit. Revisiting what this method does, it simply prints the self.name attribute concatenated with another string. Since we are calling the method on the object in robot_1, to which we assigned the name Eve during its creation, the self.name attribute returns the name of this specific object, which is Eve. As a result, the method performs its intended print operation, as shown in the output. Final note: this is the general form for defining and using classes in Python. Although it may seem complex at first glance, it is actually just a small set of simple steps that are repeated each time we define a class. With a little practice, and as we move through the remaining sections of our book, I think you'll find that working with classes is just as easy as using the print function.